In this module, you will learn to find the variance and standard deviation using the shortcut method. We know that the formula for the variance for a discrete frequency distribution is sigma squared is equal to summation of the product of the squares of the deviations from the mean and their respective frequencies whole divided by the total number of frequencies. The formula for the variance for a continuous frequency distribution is sigma squared is equal to summation of the products of the squares of the deviations of the mid-values from the mean and their respective frequencies divided by the total frequency. Many a times, the values of xi in the discrete frequency distribution or the mid-values in the continuous distribution are large. In such cases, we end up doing heavy calculations to find the mean, variance, standard deviation, and so on. To avoid such tedious and time-consuming calculations, we use the step deviation method by working with an assumed mean. Let the assumed mean be A. The deviations of the mid-values of the class intervals about the assumed mean can be reduced by 1 divided by h times, where h is the common factor among the mid-values. For the sake of convenience, we consider h equal to the width of the class intervals in a regular interval of class. Let the step deviations be yi, which is equal to xi minus a whole divided by h. This implies xi is equal to a plus hyi. Let this be equation 1. We know that the mean x bar is equal to the sum of the products fi and xi divided by n. On replacing the value of xi from equation 1, x bar is equal to the sum of the products of fi and a plus hyi whole divided by n. On simplification, the right-hand side of the equation becomes a multiplied by the sum of the frequencies divided by n plus h multiplied by the sum of the products of fi and yi whole divided by n. We know that sum of the frequencies is equal to n. Let the sum of the products fi and yi whole divided by n be equal to y bar. Therefore, x bar is equal to a plus h multiplied by y bar. Let this be equation 2. Let's substitute equations 1 and 2 in the formula for variance. On simplification, we get the variance is equal to h squared divided by n multiplied by the sum of the products of fi and yi minus y bar whole squared. We notice here that the variance that we have deduced here is in the term of variable yi. Hence, this can also be written as variance in the term of variable xi is equal to h squared multiplied by the variance in the term of variable yi. Sigma x squared is equal to h squared multiplied by sigma y squared. On taking square root on both the sides, we get sigma x equal to h multiplied by sigma y. Sigma y can also be written as shown here. This is the formula for the standard deviation in the term of variable yi. Let's find the variance and the standard deviation of the marks obtained by 25 students as shown in the table. The given frequency distribution is shown here. The total frequency n is equal to 25. Let the assumed mean be 16. The deviations of the xi's from the assumed mean, 16, are obtained as shown. As you notice here, the highest common factor among the deviations is 4. Thus, we'll take h equal to 4. Next, yi is equal to xi minus a whole divided by h. The values of the yi's are calculated as -2, -1, 0, 1, 2. The squares of the yi's are obtained as 4, 1, 0, 1 and 4. The products of fi and yi are -4, -5, 0, 7 and 4 respectively. The sum of the products of fi and yi is equal to 2. Next, the products of fi and yi squared are equal to 8, 5, 0, 7 and 8 respectively. The sum of the products of fi and yi squared is 28. The formula for variance is shown here. Let's substitute the respective values in the formula. On simplification we get the variance is equal to 17.81. The standard deviation is the square root of variance, which is equal to 4.22.